Hello guys and welcome back to another tutorial. This tutorial is going to be about the weapon system. So you're going to be able to pick up the weapon and you're going to be able to drop it as well, simulating the physics. You're also going to be able to shoot against objects and spot different particles and sound effects. You're also going to be able to reload the weapon normally. You're also going to be configuring the aim offset of the character, so the character can aim up or down like this. And we're also going to be configuring the character's state when he's holding the weapon. So yeah, those are the features that we're going to be covering in this tutorial. So let's go for it. So here we are on the game animation sample that Epic Games has created. The only things that I've added here is the hat, the holster for the pistol, and the ammo pockets. These are just accessories that I've added just so that these accessories can match the style of the character in this tutorial. So now for the first step, we're going to need to create a blueprint for the handgun. So here I think it's better for you to create a folder for placing the blueprint of the handgun. So what we're going to do is right click and go to blueprint class and choose actor. So here I have already downloaded a pistol model, which is a skeletal mesh, as you can see right there. So here we're going to simply drag and drop the weapon to the components section of the blueprint. And you're going to make sure that you have to make the handgun the new root. So that's going to avoid glitches when you're trying to pick up the weapon. I've just put a box here so that you can place and put the handgun right there. There we have our weapon. If I click on play, as you can see, the weapon is not being simulated. So I'm going to make sure that it's being simulated by default. So check that option on and make sure that your weapon has physics and physics asset assigned to it. So just to make sure that your weapon has physics, we're going to double click on the skeletal mesh, and you're going to be able to see that if you scroll down here, mine already has a physics asset. So you're just going to make sure that your weapon has a physics asset. If you don't have a physics asset yet, you can right click on your weapon. You can create, go to create physics asset and create and assign. For example, on my physics asset, be able to see that I already have added a box shape that matches the body shape of the weapon. So in reality, what's going to be simulated in the game, it's going to be this rectangle body shape and not the weapon itself. So for adding a new physics body to your weapon, you're going to right click into the handgun bone and make sure to select the box as a shape for the physics body, so that it matches up with the body shape of the weapon. And that's how it works. No secret. Now you're going to want to make sure that your body shape has mass. It's checked on. You can select the amount of mass in kilograms. I've put mine to be 20. Make sure you enable gravity. Physics type is going to be simulated. That's about it. So if you save, go back again. And now for simulating, we're going to simulate the handgun physics by default on the world. What we're going to want to do is check the options to simulate physics and check also the options to have collision. So here on the collision presets, you're going to choose custom. For the trace responses, if you're doing traces to detect the weapon, it's good to have this option on. So make sure it's block. Camera visibility is going to be ignored so that it doesn't glitch with the camera. Object responses is going to be all true. Okay, and make sure the collision enable is set to physics only. And the object type is going to be as world dynamic. Now if you press play, as you can see, the weapon dropped. If I drop it from a high distance, as you can see, the physics is now working. So now the first step was to create the handgun blueprint, set up its physics, and make sure that the physics work. Remembering the little code I've wrote here, I've coded here, is the slow motion. So if you press 1, you have the slow motion effect. It's pretty much simple. You just have to get this node here, the flip-flop. What that means is that if you press 1 again after you pressed it once, it's going to go back normal time dilation, right? So if you press once, it's going to go slow motion. If you press twice, it's going to go back to the normal default time. The next thing we're going to do here is I'm going to find a separate graph, like a distant one. Firstly, create a variable called has handgun. It's pretty important so that we can know if the character has the handgun or not. Now we're going to drag it to the graph and you're going to get the branch. But first, we're going to select the key that is going to be served as a way to pick up the weapon. So I'm going to use the F key and I'm going to search for the F key node. So whenever I press the F, it's going to go to a branch. And here I'm going to decide what I'm going to do after we read this variable. Make sure that it has the handgun default value is set to be false, because when we start the game, we don't have the handgun unless you do. So you have to set this option true. But in my case, it's not. So now, as we have the blueprint and the gun, we just have to find a way to get its reference inside the code. So when you press F, has handgun is going to be false. And what we're going to do to access the blueprint of the handgun, we're going to get the actor of a class. And here we're going to select the handgun. So now here we're checking if the character is holding. And here we're going to search for a gun in the world. Now here we're going to check if that gun is valid. What that means is that after this node, this function gets the variable, we're going to make sure that it exists in the world, right? So to do that, if this node comes out to be is valid, that means that the weapon is in the world. So if I press F, as you can see, it's printing hello, which means it's valid, right? So what we're going to do is just promote that to a variable so that it's easier for us to be able to access its variable later. As you can see here, we have a new variable. We're going to connect that to is valid. And we're going to name this variable to be BP handgun. Like we have options to get actor location, get the actor rotation, blah, blah, blah. If I were to destroy the actor just to test if it's working, I can. So whenever I press F, like the blueprint just simply disappears because I have destroyed the actor. So this is just the steps that we can use to make sure that the reference is working. The next thing we're going to do here is just because when we get close to the weapon, we're going to want to make sure that we have a system where it identifies whether the character is close to the weapon or not, so that we can pick up the weapon, right? So what we're going to do here is just get the difference between two vectors. So what we're going to do is get the actor location. And this is going to get my actor's location, the location of the character. And if we drag off from this output pin here, we're going to get actor location. So what this is going to do is going to get the actor location of the weapon. So combining these two values, we can do a math to find the distance between these two vectors. Now the result value is going to be the result. So we can print out to see what are the values. So we have to debug to see which values we're getting. So as you can see, if I press F here, as you can see, we get two different values. So as you can see, if I get close to the weapon, I get 70. If I get a little bit far away, I get 100. So I think a value of 100 is going to be a good value. So what I want to do here is if the value is less or equal than 100, then this is going to go to a branch. And if it's less or equal than 100, then that means that the character is going to be able to pick up, right? So I'm just going to type can pick up just for debugging test purposes. So here I'm pressing F, can't pick up the gun. And if I press F or I'm close to the gun, I can't pick up the weapon. This code here is going to be check the distance to the gun, something like that. Now we're going to prepare the gun for pickup. Now we know that as soon as you're close to the weapon and you're able to pick up the gun, right? Now we know it. So the next thing we're going to do is just to simulate the physics of the weapon, right? Because when you're attaching the character, like the weapon to the character's hand, you're not going to want the physics to be simulated. You're not going to want the weapon physics to be simulated to the character's hand while the character is holding the weapon, right? So if that makes sense to you, let's follow up the code. Now, the first thing we're going to do here is just get the blueprint. Now, remember, when you get the reference of the blueprint of the weapon, which is this one right here, so we can access that skeleton mesh called skeleton S-key handgun. So you can access the skeleton mesh, and you can set the simulation off by doing so. After you set the simulation off, you can set the collision object type of the gun, and you can set it to be word static. Now, then later you can set the collision enabled to no collision, so that way you can prepare the gun for pickup. Now, after we prepare the gun for attaching, now let's just attach the gun to the player, right? So we're going to get the same references here, and we're going to say attach component to component. So what this node does is, well, this node is it's a built-in code in the engine, and what it does is it attaches one component to the other. So you're gonna want to make sure that you have your component mesh, your mesh component of the character here, and your mesh component of the weapon in here. You're gonna want to make sure that the mesh is the parent and the target is the skeletal mesh of the handgun. Okay. So for testing purposes, we're going to be using the hand_r bone to be using it as a socket reference for attaching our weapon. And also make sure you select the snap to target for all the 3 options we have available. If you press on play here and if you press F, as you can see, the character's the weapon is not right on the character's hand. So that's why we need to create a socket. So creating a socket will allow us to basically define where exactly you want the weapon to be placed on the character's hand. So to do that, you're going to select the mesh. You're going to double click on the skeletal mesh. And you're going to select the skeleton here. And here you can create a new socket. Now let's type here hand R. We want to create a new socket because that's going to allow us to basically move where exactly you want, in this case, the pistol be. So it's going to name this hand_R handgun. And we're going to just simply add a preview asset just to preview how the handgun is going to be in the character's hand. So as you can see here, you can rotate the weapon to match the character's hand like that. So just by doing this, and of course you have to change the socket there on the socket name here. It has to be the same. It has to match the name. So it has to be the same name as the socket. So if you press F when you're close to the gun, as you can see, it matches the character's hand perfectly. And then you can proceed with the rest of the code. After we attach the weapon to the character's hand, we can update a variable called hasHandgun. And here we can update the variable state. So in case the character has picked up the weapon once, and if you press F again, this execution line is going to be executed. So whatever code you put in here is going to be executed. So the thing that you want to do here is just to drop the weapon with physics, right? So to do that, what you're going to want to do is call the node called detach from actor and call up the handgun blueprint to here. And for the transform values, we're going to keep world, keep the world transform. And for preparing the gun for simulating the physics back again, we're going to switch the execution flow. So firstly, we want to set the collision object type back to world dynamic. And for the collision enabled, we're going to choose physics only. And we're going to simulate the physics back again. So as soon as you press F again, as you can see, you can drop the weapon. And after you do everything, after you simulate the physics, you want to make sure that you also update the variable state, because just to let the code know that you have dropped the gun. and it has to be false. So when you can drop the weapon, you can pick it up again. You can drop it again. That's it. So what I've just showed you is how to pick up the gun based on the distance of the character relative to the gun, and how you can be able to manage the handgun collision when picking up or dropping. Now for the next step, we're going to play the animation of the character picking up the weapon, because right now you just attach it to the character and it just snaps to the character's hand. So what we're gonna do is find the pickup animation of the character. So I've already created a montage here with all the... Just delete this. I've already created a montage of the animation sequence, which is this one right here. So to create a montage, you just have to right-click, create, and create animation montage. And for the animation montage, I have two sounds, one for picking up the weapon, and one for reloading the weapon. Right. Now inside of here, we're going to what we're going to do with that. So what we're going to want to do is to create a montage notify window. Okay. Because as soon as the character touches, as you can see there, it touches the table, we're going to want to make sure that this starting location of the montage notify window is where the character is picking up the weapon, right? So poop. And on the character's blueprint, we're gonna want to make sure that we play a montage before we can attach the weapon to the character. So we can play the montage here. Just select the montage, and as soon as the notify begin is triggered, we're going to attach the handgun to the character's hand. So firstly, plays the montage. Right after he plays the montage, it attaches to the character. So we can do that in slow motion, as you can see right there. So this is going to give a little bit more realism to the game when the character is picking up the gun. Also, you're going to want to make sure that you have a separate slot for playing animations, especially handgun animations. So we're going to create a new slot called handgun slot, and you're going to assign this handgun slot to the animation montage. And here on the sandbox character, if you go to the animation graph, you're going to type default slot, and here you're going to select the handgun slot so that you can play the animation montages specifically for this slot right here. So whenever you play a animation of picking up the weapon or similar things, you're going to override all the previous logic that is in here, that it's by default in the motion matching system, which is going to prevent issues with IK or stuff like that. Now we're going to be building the character's state, the weapon state. So right now, when you run or walk like this, as you can see, the character does not have a pose of him holding the gun like the way it should be, right? The character is just normally walking, it doesn't have any pose, so it doesn't feel realistic. It doesn't feel like the character is holding a weapon. So to change that, we're going to apply a sort of like an additive pose. So we're going to apply an animation called ALS pistol. So as you can see, we have different poses on the same animation sequence, as you can see right here. So I like this pose a lot. It makes that the character is ready for attacking with the pistol. So as you can see, his right arm is a little bit up, and we're going to want to apply that pose in the characters, inside the character's animation blueprint, right? So how do we do that? Firstly, we don't want to only apply the ready pose. We also need to handle how the character is going to be able to aim with the weapon. So for that complex condition that we have right now, we're going to have to create a new state machine, right? So we're going to right click on the empty graph and search for the node called state machine. And we're going to call this pistol or handgun or weapon state machine. So inside of the state machine is completely new, it's completely empty. We're going to create the first state, which is going to be ready. The second state is going to be aim. And of course, we're going to have also the reload state. We're going to create a new, we're going to save the cache for the locomotion because we're going to use it inside the state machine. So we're going to type locomotion. And here on the inside the ready state, we're going to call that cache. We're going to call that cached pose. And now we can use the ALS pistol. We're going to convert this into a single frame animation. And we're going to get the layered blend per bone. And here on the right panel side, we're going to get the, we're going to select a new bone to be added here. So we're going to write clavicle R. For the blend depth, it's going to be 1, so that's going to be a little bit subtle. And we're going to connect that to the output pose. So what that's going to do is going to get the base pose, which is the normal locomotion, right, from the motion matching. And I'm going to apply a blend pose to here. And it's going to be just a single frame of the animation. So the frame that I'm looking for inside this animation sequence here, of course we have a lot of poses, so you have to specify which frame of the pose you want to apply to your character. So in my case, what I want to do is get this pose on this frame right here, 0.08, so that the character can be able to hold his gun like this, like he's holding here, right? So as I want to apply this only for the right arm, I'm going to get the right clavicle. So if you can like show character and bones and show our hierarchy, if you select this bone right here, you can see that we have the bone called clavicle underscore R. And if you move that, you're going to be able to see that almost the whole arm moves together with the character. So that's the bone that we're searching for, right? So that's why I've added that bone to be listed on here, so that it only affects that bone as a blend pose. Okay. So on the here on this on explicit time, we're going to type 0.08 because that's the frame of the animation that we want to be applied there. Now we're going to select and go to the source. So as you can see that the character is now holding his weapon differently as the way it used to be. So as you can see, if you turn around, like it feels very nicer. It feels like the character is really holding the gun, you know, it really shows that it certainly gives another feeling to the overall character's feeling, overall character's appearance pose. So now it really feels like the character is holding the gun, and it's a lot nicer to see that. So of course I don't want my character to be standing like this on the same pose. So what I'm going to do, I'm going to use the same variable that we used as soon as we get the weapon. So the variable that we have to read is this has handgun, right? So this variable is going to tell us whether the character has the gun or not. So using that information, we're going to be switching between the pose of him holding the gun like this, and of him just normally walking on the ground. Okay, so we're going to use the blend by bool. So that's going to switch and decide if you want to use the weapon state machine, or we just want to use the normal locomotion, right? So for accessing this variable that is inside the character's blueprint, right here inside the animation blueprint, you can use the property access. And you're going to search for sandbox character and search for handgun. So here we have the option called has handgun. And we're just going to connect that to the active value right there. So here we're going to choose the aim locomotion. So as you can see right here, as soon as I compile the game, As soon as I compiled the project, as you can see, the arm of the character just came back to be normal again. Now if I press on play, and then as you can see, I have the normal locomotion of the character. I don't have the, the ready pose of the pistol on the character. So as soon as I pick up the weapon and I wait for a little bit, as you can see, I still have the normal, the ready pose of the pistol. So that's what I want. Now let's go back and go to inside the state machine, and we're going to create a transition rule. And for this transition rule, we're going to create the transition rule. So we're going to get the AO value, and this we're going to go absolute float. We're going to do 73. We're going to access another variable in the sandbox character called wants to aim, and that gives us the variable, the information if the character is currently aiming or not currently. So I'm going to do that again. Property access, and I'm going to access the characters variable called doing traversal action. Because if we're doing a traversal action and we're aiming, we're going to stop aiming, right? Or we're not going to be able to aim if we are doing a traversal action. Now for the aim state, we're going to get the variable called now for the aim state, we're going to get the animation called poses pistol 1H. We're also going to select a single frame of the animation called, it's on the frame of 16. So as you can see, the character is aiming like this. So I want to use that single frame of the animation. And I also am going to use the layered blend per bone, and that's going to be connected to the blend poses. And we're going to use as the base pose going to be the normal locomotion matching system. The commotion of the motion matching system. Now here for the layered blend per bone, we're going to add a new bone here called clavicle R. The blend depth is going to be 1, and the mesh space rotation blend has to be turned on, has to be true. So let's test it out to see if it works. So as you can see, I have a little bit of distortion on the bone, but that's just a matter of changing the animation. Because right now I use the animation that it's not really from the motion matching pose. So there is a little bit of distortion there, but I believe that could be fixed changing the aim pose animation, or making a pose animation that matches the base pose. Alright, so going back to the ready state. Going back to the transition, so this one right here, this transition is going to just make sure that if aiming backwards, don't aim. If aiming backwards, don't aim. And this is just wants to aim if character is aiming. If aiming. Aim. If doing traversal action, don't aim. So we're going to just basically copy this, and we're going to do the transition rule going back, going from aim back to ready. And we're going to just basically paste all the condition rules that we've just wrote there. In here, instead of just 73, it's going to be greater or equal instead of less or equal. We're going to do 73 again. And here you're just going to switch. So this is going to be part of this. And we're not going to get the end, we're going to get the upper boolean. We're going to add a new pin here, and we're just going to connect the traversal actions, all the necessary output values in there. Make sure if character is aiming backwards, character should stop aiming. I don't know if that makes sense, but so if you suddenly change direction and start aiming backwards, you just want to make sure that the transitions, the aim transitions has to go back to ready because the character is not aiming to the direction that it's supposed to. All right, so for now, we're going to be creating our reload system state. So for that, we're going to create our new variable called reload. Its type is going to be a boolean. Right now, I think the commonly used key for reloading, I think it's the R key, so we're going to use that. Now we're going to drag our reload variable and set it to be true on here. And the other one is going to be false. Now, of course, we're going to set a delay so that the animation blueprint can know that we are reloading the weapon. Now, this is a pretty simple state and system that we can set up. Now, let's go back to the animation blueprint and set it up like right here. Firstly, we have to set up the animation inside the state called reload, of course. Now, for the reload state, we can drag and drop our animation called UFN HG reload. And inside this animation sequence here, we have 3 sound effects. So one is for picking up. The other one is the character, filling up the space for the ammo in the gun. And the other one is that one that you see right there. So we have 3 sound effects that complete the animation. As I want this animation to be played only on specific bonds of the character following the hierarchy, I want to get the layered blend per bond. And this layer blend per bond allows you to choose which specific bond we want to play the animation. Now, just make sure that the execution pin is plugged into the blend pose, because that's the pose that we're going to be able to blend. Now, here from the base pose, we're going to be searching for the locomotion cache. It's like retrieving a variable and reading it and then plugging it to the base pose so that the layered blend per bond can configure and know which one is going to be the base pose and which one is going to be the pose to be blended. Now here on the layered blend per bond, we can set up our bounds. So here I'm going to write clavicle R for the first one, and for the second one is going to be the clavicle left of the character. Now here it doesn't matter the order, you can place the clavicle R, the clavicle left here first, and secondly you can place the clavicle R, so it doesn't matter. For the blend depth, I think 1 here makes the difference, so I'm going to put that in there. So that's all the settings that you got to do in here. So all you got to do is just plug that into the output result. And now inside the state machine, we have to allow the reload state to be active, right? So for doing that, we're going to drag the pen to the reload. So that means that if we are on the ready state, we can go to the reload based on the condition that we're going to put in here. Now the condition is going to be pretty simple. We're going to access this variable right here. We're going to read it inside the animations blueprint. So we're going to do property access, which is going to allow us to access this variable that is inside the character's blueprint, inside our animation blueprint. So here we're going to type sandbox character and type reload. So we're going to be able to find the reload variable and connect it to the result there. So what that means is that if we are on the ready state and if you press R, of course this variable is going to be set to true, which means this state is going to be going from ready to reload. So we're going to test that out to see if it works. We're going to grab our weapon first. So if you press R, as you can see, the characters arm is... As you can see, it worked, but now the character is stuck on the state because there is no transition rule. Because there is no transition rule going back to ready, right? So we're going to set that up. So all you got to do is just plug that into back to ready and click on here on the transition rule going back to ready, and click on the automatic rule based on sequence player in state. Turn that to true. So what that means is that as soon as this reload variable state, as soon as the animation is completed, as soon as the reload animation is completed, this transition rule is going to go back to ready. So what that means is that as soon as the reload animation is completed, we're going to be able to go back to ready as soon as that animation is finished. Now all you gotta do is just be able to do the same thing. We're going to go from aim to reload. So that what that means is that if you're aiming, then if you press R, you're going to be able to normally reload as if you were as well on the ready state. So we're going to basically copy and paste the same reload condition, transition rule condition in here. So copy paste that in there, and if you press on play, you're gonna be able to reload even though you're aiming as well in the ready state. So as you can see there, it works. So you're going to be able to reload regardless of the state you're currently in. Now, if you want, you can play also an animation for the gun itself, not the character, but you can also play the animation for the gun. So I have a animation for the gun that it's called reload, handgun reload, which basically puts the magazine, I don't know if that's called a magazine, but basically it shows the animation for the gun. So if you have like a separate animation only for the gun, then you can play that as well. So you can just play animation, and you can get the reference of the gun, and then get the reference of the skeletal mesh. So that's going to be the S key handgun. And you're going to select the view animation to be played. In my case, it's this one right here. In my case, it's this one right here. I think this animation here is commonly used when you have a first-person project where you have to see the gun reloading, right? Now we're going to set up some arrows to represent the direction of certain visual effects. Let's say, for example, you don't know where exactly the bullet is going to come out from. So placing arrows inside the blueprint is going to allow you to have control of how the particles are going to come out from, and it's going to be easier for you to later adjust where exactly those particles are going to be at. So for that purpose, we're going to create arrows. We're going to add arrows inside the blueprint of the handgun. Now we're going to select and add our first arrow, and this first arrow is going to be used for representing the bullet projectile. So what we're going to do right now is set the scale of the arrow so that it fits the gun. So let's say .2. So the red arrow is going to represent where exactly the bullet projectile is going to come out from. I'm going to set the color of this arrow to be yellow so that the next arrows I can differentiate the color. So for the next arrow is going to be for the shell particle spawn. So I'm just going to name the next arrow to be shells, to be named the shells, and the color is going to be green. And we're going to be placing that arrow right where the shells usually come out from. And that's about it for now. So we're going to use the location, like the forward location of this arrow, to make the representation of the gun's aim. So we're going to do a line trace for the handgun right now. So that's going to be better for us to visualize where exactly the gun is aiming at, and the game is going to be the game is going to feel a lot nicer when you add a line trace for the gun right now. So we're going to utilize the event tick for that case. Many people don't like it, but for this purpose, as we're doing some tests, we're going to be using the event tick for now. But you don't necessarily need to use the event tick for that. It's just for debugging purposes, right? So what we're going to do is call a line trace for channel, line trace by channel. And we're going to connect the execution pin of the event tick in there. As we want to access the arrow inside the handgun, we're going to get the handgun blueprint reference and get the, what is it called? Bullet projectile arrow reference. Now we're going to want to get the forward vector of that arrow. So that's going to get the forward vector of the arrow, which is going to be pointing forward as it is right now in here. Now, if you do it like this, if you rotate the arrow, then it's going to be pointing to the right. So just make sure you align the arrow with the pistol, like so. Now we're going to get the world location, and you're going to want to multiply that, because that's going to be like whatever number you put inside there, it's going to be the distance of where the line trace is going to reach. So the line trace is going to be a line, and the length of that line is going to be the number you decide to put in here. So that looks fine. Now for the draw debug type, we're going to select the one frame, and when you press on play, oh yeah, as you can see, I got a lot of arrows, and that's because as soon as you execute the game, as soon as you run the game, the event tick is going to be triggered. And as we don't have a function to get the reference of the handgun, it's going to be false. So what that means is that we're going to have to get the BP handgun and convert it to a validated get. And what we're saying is basically, if the gun is valid, if the reference of the gun is valid, then we're going to spawn the line trace by channel. This execution here, this logic is only going to run if it's valid. So that's going to prevent issues like I just have right now. So as soon as you pick up the gun, as you can see, it serves for showing exactly where you're shooting at, and that's very nice. So for now, we're going to be setting up the bullet. So the first thing we're going to do is create a blueprint for the bullet. So I have a static mesh for the bullet right here. It looks nice, as you can see right there. That's my bullet. It could be any static mesh, it doesn't matter. So we're going to right click on your static mesh of the bullet you're going to be using for serving for the bullet. So we're going to go to asset actions and create a blueprint using this, and we're going to name the bullet to be, I don't know, go inside the blueprints, go to bullet folder. If you don't have a folder for that, just create one. And this is going to be called BP underscore bullet. So now we have the blueprint for the bullet. Now what we're going to do, how that works is that when you spawn the blueprint, the bullet is going to be spawned, and the initial velocity is going to be set by adding a component, right? So we're going to add a component to the blueprint of the bullet, and that's called projectile movement. Now, as soon as you set the initial speed and blah, 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 all those numbers that it's needed so that the static mesh can have its own initial velocity. As soon as we spawn that blueprint, then the blueprint is going to be flying, like the blah, right? It's going to be whoa. It's going to be wow. Like, wow, man, nice. So we're going to use the yellow arrow as a reference to spawn the bullet projectile in the right direction. The first thing we're going to be setting up right now is the projectile movement, because that's the most important component that we have to set up initially, because that's what's going to make the static mesh to go boom. In the initial speed setting, we're going to set up 20,000. as for the initial speed, and for the max speed is going to be 10,000. Make sure you have this rotation follows velocity to be true. So the rotation follows velocity means that if true, this projectile will have its own rotation updated each frame to match the direction of its velocity. And all these other settings here, I don't change much. Now, the projectile gravity scale, you can set it to be 0 so that there is no gravity. But that's a personal change. If you think that the bullet should be affected by gravity, you can set this to be true, or that means like 1. You can set it to be 1. And if you think that the bullet is falling a little bit slow, you can increase this number to be like 5 or 10, whatever value that it's needed for your project. But I'm going, like in my case, as I want the bullet to follow exactly the direction I'm shooting at, like ignoring the gravity, I'm going to set this to be 0. So for that case, I'm going to set this value to be 0. I think that's pretty much the settings that you need to change in here for the projectile movement. So now I think we can try to spawn our bullet, right? So to do that, we are going to choose a key so that we can spawn the bullet. So we're going to choose our left mouse button to do that action. So for making the gun to shoot the bullet, we're going to spawn a actor from class, and we're going to select the blueprint that we've just created. It's called bullet. Now this path transform, we're going to use the arrow as the reference. I think that's pretty much it. We're going to get the handgun reference, and then we're going to get the bullet projectile. So we're going to get bullet projectile. Now we're going to get its socket transform. So by getting the socket transform, we have multiple values. So we're going to split the structure pin, and we're going to connect the rotation. We're not going to connect the scale because that's going to mess up the size of the bullet, as we have custom scale for the arrow inside the blueprint. So that's pretty much it. I'm going to turn on slow motion so that you guys can see how the bullet is going to come out from the gun. But before that, we're going to check out some settings inside of the static mesh. So you're going to make sure that the collision settings, in this case, is going to be set to be custom. The object type is going to be world dynamic, and we're going to ignore all the trace responses and object responses for that specific static mesh. And I'm going to explain why later. And also here for the collision enabled, we're going to choose no collision. And let's try to pick up the gun and try to shoot for the first time to see what happens. Whoa, that's pretty big. The right scale value is here, it's 0.5. Yeah, the bullet is going to be like, the bullet is pretty big. I think we're gonna have to set up our box collision first, because what the box collision is going to do, and the reason why I said the static mesh should be no collision, is because the box collision is going to determine where the bullet will hit. So that's like encapsulating the bullet itself, so that the box is going to be the actor that is going to collide with the other objects in the world. So right, so by doing this, because like the box has all its properties for like getting the information of where the bullet hit, what exactly is the material, like what's the actor that it's being hit. So we can get all the information by retrieving, like let's say like this, for example, we can get all the component information and other actor informations, the hit location, the hit time, hit normal, hit impact normal. So we have all these informations that we can retrieve from the box collision and not the static mesh, right? I think the static mesh also has its properties, but I prefer using the box collision. So by doing so, we can set our box to be the new root. So as you can see right here, before we couldn't see these options called rotation, location. So that's why I used the box collision first. And yeah, so now we're going to be setting the transform values of the bullet only, the bullet static mesh. For here on the rotation, I'm going to put 90 because the bullet was spawning on the wrong direction. And for the location, I'm going to type -32 so that I can fit the size of the box. Now for the box size, I'm going to choose 0.04. So when I shoot, as you can see, the bullet is, I think the size is correct. And that's about it. Now we're going to be setting up the box collision settings, and we're going to set up the hit component, and we're going to set up the collision settings as well. For the collision enabled, we're going to choose the physics only, collision enabled, query and physics. We're going to keep word dynamic, and we're going to select all these options here to block. And we're only going to ignore the visibility for the camera because we don't want the bullet to be glitching the camera. Even though that's going to be a case that's very hard to happen, but just to make sure that everything runs well and smooth. So what we're going to do now to set up the event hit for the box collision, you're going to click on the box collision. We're going to go here on this plus sign and then click on that for the on component hit. So we're going to get this node right here, and we have a lot of information, especially the one that we mostly worry about is the hit structure result. It's the hit result structure. So if you right click on that and split the structure pin, these are the informations that you can get after the bullet hits something, right? So let's say if you want to print the name of the object that the bullet has hit, then you're going to just put that in there. As soon as you shoot with the bullet, then that information is going to be displayed on the screen. So let's shoot on this object here. And as you can see right there, it says level block traversable. And that's just going to make sure that we are getting the information of the hit actor. And now that we've checked that everything is working well, we're going to get the actor of a class. So we're going to connect this to here, and we're going to select our CBP sandbox character. And in this case, it's going to be the parent. So the parent in my case is the sandbox character. And we're going to promote it to a variable so that we can access it later. So to make sure that the reference of the character is valid, we're going to get the node is valid. And we're going to promote some values so that we can use later. So we're going to promote the hit impact normal to a variable. We're also going to promote the hit impact point to a variable so that we know where exactly the bullet has hit. We're going to also promote the hit actor and promote it to a variable as well. So after we've done that, we can be happy to execute the other code, whatever code you need, because those are the most essential information that you ever need for completing this tutorial specifically. So as each object is going to have their own impact effect regarding like sound effect and visual effect, we're going to use tags to differentiate objects. So I have displayed here as a target object. Also have multiple. So I'm going to just turn this right. So as our system is going to work based on tags to identify which type of surface we're hitting with the bullet we're shooting at. In this case, we're going to use tags. So if you click on the model and go to the details and search for tag, and click here on this plus sign to add a new tag, you can add a new tag. Now, for this case, as it is a metal object, I think it is, I don't know. So I'm going to type metal. And in this one, as well as it is a metal object, I'm going to type metal again. And for this one, it's going to be wood. So wood. And of course, if you have other objects like glass or grass, I don't know, you're going to type the tag in here. Just make sure that you have to add the tag. Just make sure that you add the tag below the actor, which is like actor, then comes advanced, and then tags. Make sure you add the tags in here and not on the component tag, right? The next thing you're going to do is make the code to identify which object has a tag. So now for doing that, of course, we're going to get the hit actor, and we're going to get a node called has tag, actor has tag, and then you're going to simply type the name of the tag that you've added there. So in my case is metal, and I also have the tag called wood, right? So we're going to get a branch like this. So in case if you're hitting a metal, we're going to of course spawn a sound effect at location, and we're going to be able to select the sound effect that you have. So here you're going to select the sound, the wood impact sound that you have on your project. In my case, I have this wood sound effect. I've created a queue and I've added some sound effects. Actually, I've added only one sound effect actually, and a modulator to randomize a little bit the pitch and the volume sounds. Offsets, right? So right now I just have a simple wood impact sound effect just for testing purposes, right? And of course, if you're hitting a wood, of course this is wood, and I'm going to also have a separate node for spawning a impact of the bullet hitting the metal. So you're going to have a metal impact sound effect. Now for the metal impact effect, I have this sound right here. It's a cue as well. So here I have some randomization of sounds. So if you want to copy my setup, I've just added a bullet sound effect, a bullet metal impact sound effect. I've got a mixer so that I can mix between this sound and this sound as well. I also have another mixer. So that I can also choose between this one and this one. You can also combine the sound effects between this one and this random output here. And it goes to another random so that I can select either this execution line of the sound or this one right here. And the modulator, you can also use this to randomize the pitch and the volume, minimum and max values, right? And then it finally goes to the output, which then you have the final sound effect customized. So right now I'm not going to input any location values right now, just to test it out and see if it works, right? As we have the tags set up and added to each object, so we're going to test to see if it works. Yes, it's working. Now let's see if the same sound happens on the wood material. No, it's not happening. Let me see why. Condition. Looks like I was missing a attenuation setup. So if you don't have a attenuation file like this one right here, you can right click and type attenuation, sound attenuation, and then you can give it a name. Let's say at test. Then you can double click on that. So basically how this works is that based on the distance of where you are currently in the world and the distance of the impact sound effect, the volume of the impact sound effect is going to be based on the distance of where your character is at in the world. So if you want to follow the same settings I have here, just be free to follow. This settings here on the attenuation impact. So all this is set up in a way that it works pretty much fine for this purpose here, right? So if you want to copy the settings, here you go. And that's basically it. So for all the impact sound effects, I'm going to use the sound attenuation settings here. So going back to the bullet blueprint, I'm going to also select the attenuation impact that I have created before to be this one right here. Once you're hitting a target with the bullet, you're going to want to play different sound effects, decals, particles, right? So for that purpose, we're going to create a function so that it's going to handle everything. So we're going to create a new function called impact effects, so that it's going to handle the impact effects that we're going to be customizing it, like customizing the parameters so that it can handle different impact effect depending on the object material you have set up, depending on the material that the bullet hit. Right, so the first thing we're going to create, actually what we're going to do is cut this spawn sound at location here, delete this as well, and delete this, and delete this as well. So we're going to go back to the impact effects and paste that spawn sound at location here. We're going to also get the node called spawn actor from class, because we're going to be able to spawn a decal effect. So here we're going to select and get a sequence. For those who don't know, if you drag off this and press S while you're holding that, you can get the sequence. Now for the second impact effect we're going to have is the sound, right? So we're going to connect it here. As for the third impact effect, we're going to spawn the particle. So we're going to get the node called spawn emitter at location. And we're going to drag off this pin to here and organize this a little bit better. Now for the location, we're going to drag off the impact point variable that we just created there before. I'm going to put this node a little bit below right here, because we're going to split this spawn transform here, and we're going to want to place the same node in here. It's going to be the hit impact point for all of the three nodes. So this node here is for spawning the decal. So I'm going to type here spawning decals. Now, if you compile save, I have some arrows here. Of course, I have to select the class. But ignoring that for now, if you drag and drop the impact effect function that we've just created, as you can see, we don't have any parameter that you can set inside of here, right? Because if you duplicate this and connect this to here, you're going to be able to select the different decal effects, sound effects, and particle effects inside this function right here. I think it's a lot more easier to manage those impact effects, right? So what you're going to want to do is drag off the class to the input pin here and press on compile. So if you go back, as you can see here, we have a class parameter as we have a class as a input parameter, so that we can choose, like, let's say, for example, the decal. In this case, is the decal. We can select any decal right here. Now, yeah, that's basically it. So we can basically organize the blueprint better. Instead of doing this, you can just call the decal class, which is the same thing, right? You can either do this, which is fine. But if you can organize the blueprint a little bit better and call the decal class like this as well, it's the same thing. It's going to read the same variable, so that doing it this way, we can organize the code better. So we're going to compile, save, and that's about it. Now we're also going to plug the sound effect into the input pin. So if you come back, as you can see, we have the selection, the sound selection that we can do, that we can select in there. So I'm going to do the same thing. This sound effect is going to be for the impact sound effect. So I'm going to type impact sound, or sound impact, or just sound. Let's do, yeah, I think we can do just sound. And then to access this variable that is going to be output here, we can get the sound, right? It's the same variable, so we can put in here, and it's going to execute perfectly. And the next node, we have the emitter template. So we're going to do the same thing. We're going to put that in here. I'm just going to type emitter, unplug that, and then I'm going to get the emitter variable. Scroll down, you're going to be able to see that we have the emitter here. So we can connect it here so that we can organize all the code better. Now, what we can also do is get the attenuation settings. So sound attenuation. This is going to be sound attenuation. Now this is going to be sound impact sound. This is going to be impact sound. We're going to also get the sound attenuation variable again and plug that into here. So now if you go back, you're going to be able to see that we have a bunch of parameters that it's been added as soon as we plugged the value pins to here, to the inputs of the function. So here I'm going to select the impact sound effect again. On my case, it's metal. So this is mine. And for the wood, this is the impact sound effect that I have for now. And let's test it out to see if it works. Not for the wood, so let's see what's wrong with the wood. Yeah, I forgot to select the sound attenuation. So in my case, it's ATT impact. So make sure you select for both the sound attenuation, and let's try again. Yep. Okay, as you can see, it's working. Now, what I'm going to do is create a new decal effect, right? So to set up mine, I already have a decal effect. Decal, as you can see, I have the wood decal effect, and I also have the metal. I also have the metal impact effect. So I have two decals for different materials, for different object types. So what I'm going to do is create a blueprint using this, but I'm going to have to create a blueprint from scratch. So go to blueprints, decals, and right click. If you don't have that folder, decals, just create one. We're going to select blueprints, actor, and let's say this is a decal, wood decal. I'm going to duplicate this. This one is going to be called metal decal. Okay, so we're going to go ahead and open the metal decal, open the full blueprint editor, and here we're going to just drag and drop the wood, the decal bullet wood, to the default scene root. Let me see if I can do that. No, I cannot. I guess I'm going to have to add a component called decal and select the decal material through here. So we're going to type wood, decal bullet wood. And if you click on the viewport, you're going to be able to see that as soon as this trigger box overlaps the type of overlaps a surface, is going to be the decal is going to be applied to it. The only thing you can do here is try to change the scale so that it fits. So let's change the scale. I think the scale value is too much big. So we're going to lock. Make sure that the scale is locked, and let's choose a value like 0.10, like so. And also for the wood decal. So we're going to add a new decal component and change the scale to 0.10, 0.1, and change it to be the decal that you want. I think everything is ready for spawning the decal. Now we're going to go back to the bullet blueprint and choose here on the decal class, as this one is the metal, so we're going to select decal metal. So blueprint metal decal. So the decal works like a sticker. Like if you place the sticker on the wrong direction of relative to the surface of the object, it's going to look weird, right? So, oh yeah, this is for the I think. Wait, something bad happened here. I don't know what. Yeah, I've changed it. It's not that one. It's It's not that one. This is the right one. Okay, so make sure that you have the right decal material in there. And let's try it again. As you can see, this decal is pretty huge. And it's not spawning on the right side. So to fix that, let me just select the decal class for the wood. So wood decal. And I'm also going to select, make a system where it's going to, the rotation of the decal is going to face exactly the rotation of the blueprint. Sorry, it's going to face the exact location of that object that is being hit. So to do that, we're going to get the impact normal. And we're going to get the rotation from X vector. And then we're going to promote that to a variable. And we're going to call this rotation from X vector. We're going to promote that to a variable. Now we're going to retrieve the rotation from X vector value and then get the forward vector. And then multiply it by 1. Multiply by 1, and then add with the impact point location of the surface, and then plug that into the transform location. Now for the rotation, we're going to get the rotation from X vector. We're going to split the structure. We're going to subtract it with 180. And we're going to put that in the spot transform rotation ZR. Now for the spot transform scale, I think we're going to plug that into here and then get the spot transform scale so that it can be better organized. Just for reference, we're going to name this decal spot scale so that we know which type of scale we're going to be messing around. We're going to be changing, right? So spot decal like that. And going back here on the function for as a parameter for the decal and spawn scale, we're going to type .5. But this is going to be relative to the size of the effect you have, of the decal you have. And for the wood decal, we're going to actually this one is going to be .5 and this one is going to be . So here on this value here, you just have to figure out what's the best value for the decal scale, and basically it. Let me just put this. This is getting a little bit long. So what else? What else can I do? Yeah, of course, the spawn sound at location. We can change what's going to be the volume multiplier before the sound gets spawned, right? So of course, we're going to select and make the volume to be relative to where the character is. For this case, as a single player third-person shooter. So what we're going to do is get the sandbox character reference, and we're going to compare the distance between the character and where exactly the impact location was, right? So we're going to get the actor location of the character, and then we're going to get the impact point of where the bullet hit. We're going to compare the distance. So we're going to do this calculation here. We're going to do a map range clamped. And of course, the distance is going to be depending like how far is it considered to be too much far. But in my case here is going to be 3,500. Oops. 3,500. And for the sound max, we're going to have to create a new input variable, a float variable, and we're going to name it to be sound max, impact sound max as a variable. And then we're going to select it here. So impact sound max. And the output value is going to be to the volume multiplier. And here we're going to be able to select the maximum sound of the impact of the bullet. And in this case here, I'm going to select 1 for this one, and this one is going to be 1.3 when the bullet hits the wood material. And for the metal, it's going to be 1.0. Now let's test it out to see if it works, how it reacts, and test some things out. All right. I'm gonna have to change the decal scale of the metal, so that's going to be 0.1. Just a little bit of correction there. I think that's the correct size for a decal effect for the metal and for the wood as well. All right, so I think that's pretty much done. Just missing one single thing, which is the emitter template, right? So we didn't select the emitter template yet. So what we're going to select them. So this one is going to be the wood. I have the wood impact particle effect, and also for the metal. So we're going to put those there, and let's test it out. Yep, I think it's working fine. All right, that's looking a lot nicer right now. So the last thing we're going to do here is destroy the bullet. So we're going to type destroy actor, and as soon as those impact effects gets played, we're going to then finalize the execution event by destroying the bullet itself, right? Not the effects. So the bullet is going to be disappeared after it has collided with an object. As you can see right there. Now that we just made sure that the impact effects are in place, we're going to make sure that when we shoot, the bullet sound effects and shells, particles effects are coming out of the bullet. So let's do that right now. So before we can shoot, we're going to check if the BP handgun is valid in the world. So we're going to check its validation. So let's get the isValid node and connect to here. And we also want to check if the character has the handgun, right? So we're going to get the node called isValid and has handgun. And we're going to make sure that both of these booleans are true before we can execute the function of spawning the bullet. Before we can shoot the bullet, we're going to spawn some particle effects. So the first particle effect we're going to spawn is the shell particles. So spawn emitter at location. I have a shell particle effect, and we're going to have a direction, a position of where exactly those shell particles are going to spawn from. So for that reason, we have the arrows. So with the arrows, we can get the exact direction of where the shell particles are going to come out of the bullet. So I'm going to be using the green arrow here, indicating the position of the shells, of where the shells are going to come out from. For that purpose, we're going to be retrieving the shells, the arrow named shells. So we're going to get the handgun and get the shells, which is a arrow named shells. We're going to get the socket transform so that we can get its location and also rotation. So get socket transform. Now we're going to plug that to location and rotation. All right, so we're going to connect it to here, and then let's test it out to see if it works. So as you can see, the shells are coming out of the bullet as soon as the character shoots. As you can see, the shells are right here. So it gives a little bit of more realism when you shoot the gun. The next thing we're going to be spawning is the muzzle flash particle. So for spawning the muzzle flash particle, if you have that particle, you're going to just have to select the muzzle flash particle right there. And the socket transform is going to be the same as the bullet projectile, right? Which is also an arrow. And it's the exact location of where I've built the line trace for the weapon. And it's the exact location of where the bullet come out from. So by doing that, let's check it out if it works. I would recommend you to create another arrow just for representing the location and direction of where the muzzle flash is going to spawn from. Like depending on the particle, is going to be spawned on a different direction. So I would recommend to do that. Spawn another, not spawn, but add another arrow like this. So we're going to add another arrow. This one is going to be arrow. This one is going to be muzzle particle, and I think it can be as the same direction as the bullet projectile. I think it's going to be rotated to the left because of how my muzzle flash particle is set up inside the particle system. But as soon as you get the muzzle flash direction in here, and as soon as you play, let's see if it works. As you can see, when I shoot, looks like the particle is rotated to the left. So what I'm going to do, as I'm using a separate arrow, different from the bullet projectile arrow, I'm going to rotate this to the left so that it matches the exact direction that I want to play the muzzle flash particle effect, right? So when you press play now and test it out, as you can see right there, now it's right. Now the last thing we're going to add here is the spawn sound at location. And the impact, the sound location can be the same as the actor location. Same as the actor location of the handgun. And for the sound, I have the firearm handgun. Search for that node. So I've made a simple queue so that I can select a random firearm for the for the handgun. So here you can select what it does is selects a random shoot effect. So it makes it so that it's not the same sound that you hear every time. I've also added 2 modulators so that we have variations and randomizations of the pitch and volume sounds. Yeah, that's about it. It's a very simple cue sound effect. All right, after that, we can also play a animation for the handgun. So we're going to play animation. We're going to select the handgun and we're going to access its skeletal mesh and put that to the target. And we're going to call the shoot animation, which is going to make the weapon to shoot like that. As you can see right there. It's just a simple animation for the handgun. So as we press on play and test it out, see if it worked. As you can see, the decals are disappearing after a certain distance, especially for the metal decal. As you can see, also like the wood decal also disappears. To fix that, you can go to the blueprint and click on here on the decal. And for the fade screen size, I think you can let it to be 0, also for the wood, so that you make sure that you can, like, decal visibility can be visible regardless of the distance of the character. I think it makes it a lot more realistic. I think that's a lot nicer. All right. So what I'm going to do here right now is just to organize it a little bit so that it's easier to read. So for now, we're going to fix the spine of the character not moving when you aim up or down on the vertical axis. Right, we can right now we can only aim to the left and right, but we cannot aim on the vertical axis. So what you're going to want to do is we're going to go to the event graph and go create a function called update spine rotation. And from here, you're going to get the AO value that comes, like this is the function that comes inside the game animation sample. So if you double click that, it gets the control rotation, it gets the root transform, which is calculated in here. So we're going to split the structure and get it to be multiplied by -1. We're going to get the clamp angle node. And here we're going to add 90 degrees negative and 90 positive. Now here we're going to subtract, so we don't want to oversteer the character spine, over rotate the character spine. So here we're going to subtract it by 5. And now we're going to create a new variable called spine rotation. And this variable is going to be the rotator type of variable. Now we're going to be setting it, split the structure pin, and as we want to only modify on the vertical axis, we're going to be using the X row. So now going back to the weapon state machine, if you go to the aim state, we're going to be adding some transform nodes. So we're going to get the transform bone node. And the configuration is going to be very simple. We're just going to be adding all the spines of the character from 1 to 5. So we're going to be needing 5 spine bones. We're going to be needing 5 nodes for that. So here we're going to be adding to existing. And here we're going to be selecting the bone to modify. So for the first node, we're going to select the spine 1. For the second node, it's going to be spine 2. And then spine 3 comes in place. And then 4. And then 5. So we're going to connect all of these transform modify bone nodes. We're going to get the spine rotation and connect that to all the rotation input pins of the transform modify bone. And then here we're going to disconnect this and plug this to here so that we can connect the nodes. Oh yeah, also we have to, after we created the function, we're gonna have to let it running in the event blueprint update animation. So we're going to just drag and drop that function to there and press play so that I can be updating at runtime. Right? Yeah. We don't want that. That's not good. All right, so looks like we have a issue here. We don't have to subtract, we have to divide. Sorry for that. So type 5 here and your problems should be solved. All right. Yeah, looks like the character is not good. I think it's a little bit bad. So to fix that, we're going to go to the animation graph. Some of the problems that's happening is because it's trying to blend the spine and it's trying to apply the mesh space additive, which is this normal, when you aim on the vertical axis, the character does this, right? So what we're going to try to do is modify the alpha. So now we're going to be dynamically updating the alpha value at runtime so that the character spine does not overbend when the character aims to certain angle values on the x-axis. And the reason why we do this is because we're going to want to reduce the default aim offset effect amount when we are aiming to reduce the weird overbend effect we're getting currently. So we're going to go ahead and get the AO value function. So now we're going to be getting the ABS node, the absolute value node, so that you can return the absolute value of that result. We're going to do map range clamped. We're going to select float. This is going to be here. Then this goes to alpha. Then we're going to get the property access value of the sandbox character and get the wants to aim variable. So as soon as the character aims, it's going to pick A. We're going to call the spine a correction. And here on the in range A, we're going to select 80. And here in out range B, it's going to be 1. Now these values are found by debugging the rotation of the AO value. So if you have time, you can debug the values both on the Y and X axis. Yes, I think that's a lot better. Of course, you can test other values here and like test on your own, just see which values works for you. For the last thing we want to do is when you shoot. Right now we don't have any recoil effect for the arm, right? So the arms just stay static. So it doesn't give the feeling that the character is really shooting. So for that, we're going to make the character's arm to rotate a little bit after he shoots, right? It shows that the character is really shooting, and it makes the character to feel more alive after he shoots. So for that, we're going to create a timeline. So add timeline. Let me just unplug this. Let me get the sequence. And inside the timeline, we're going to add a new float track. And the length, which is the duration of the timeline, is going to be 5 milliseconds. For the first key we're going to add is going to be at 0, 0. So 0 for the time and 0 for the value. For the second key is going to be .0660. And for the value is going to be 1. Right. Now for the third value, we're going to add .0.26.7, and for the value is going to be .0.24. All right. Of course, now if you press F, you can zoom in so that you can have a better view of the whole track. Now for the last value, we're going to set the time to be .5, which is 5 milliseconds, the whole duration of the timeline. Now the value is going to be 0 because we're going to be resetting the timeline. Now select every single curve and click on some of the curves and click on auto. So that's going to smooth out the curves. All right, so as soon as the character shoots, his arm is going to be a little bit up. The rotation is going to go up, and then it's going to slowly go down again. All right, so for that purpose, we're going to create 2 variables. One is going to be called hand R. Actually, shoot hand R, and the type of variable is going to be called, float. Now we're going to create another variable to be, and this variable is going to be called lower arm, right? Okay, so here we're going to add a lerp function, and here we're going to be updating these variables right here. And here is going to be shoot hand R. So we're going to be updating these values. And on the B value, we're going to select 1. And for then 0, we're going to go to stop. And then 1, we're going to go to play from start. And then we're going to add another pin. And then 2 is going to go to spawn shell particle. And then now we have to access this variable inside the animation blueprint of the character. So we're going to go to the event graph and we can add it here. So we're going to type shoot. We're going to get shoot hand R and get shoot lower arm R. We're going to promote them to a variable. And then we can connect them here. As we don't have many variables, we can just let it like this and compile. Now for the last, I think for the last thing for now, for this tutorial, what we're gonna do is go inside the animation graph after the state machine. And what we're gonna do here, we're going to add 2 transform bones. So transform modify bone. And for the first bone, we're going to, for the rotation, we're going to add 2 existing. And for the rotation space, we're going to add the parent bone space. Yeah, now for the bone, we're going to be adding the lower arm R. And for the second bone, it's going to be hand R. So we're going to select and connect them to here. So we're going to connect the local component to here. And lastly, we're going to connect it to the true pose. Now for the alpha value, we're going to get the hand R and also the lower arm and connect the respective variables to the respective transform modify bone. So as soon as you split the rotation values we set in here determine the actual amount of rotation applied to the character's hand. And the higher the value, the greater the recoil effect, and the more significant the rotation is applied to the character's hand. So I've set the Y pitch value to be 20 and the ZR value to be 15, as these values made the most sense to use and helped me to achieve the desired result. And yeah, I think that's enough to test it out to see if it works. As soon as you shoot, the character's hand is going to be like that. Now, if you change this value to be like 3, I think the character's hand is not going to be that much. It's not going to move that much, as you can see there. So that's just a way to customize here on the lerp value. That's just a way to customize it. If you type 2, yeah, that's just another way to customize it. I'm going to let it to be 8 for this case. And if you want to change these values here, for example, let's put 50. Let's just see what happens. As you can see, it's just a matter of like tweaking these values and seeing which value works best. I'm going to keep these values to be 20, so it works the best. Yeah, I think that's about it for this tutorial. I hope you enjoyed. If you have any questions, you can comment down below, and I see you next time.